Size. Everyone gets this. Essentially, this means how big the atom is. However, what does this really mean? For our purpose, we treat an atom as a sphere. We can describe this sphere typically by volume or radius. So whenever we talk about atomic size, we are usually using the radius for comparison. But what defines this radius then? It is the distance from the center of the atom to the boundary of the electron cloud. Nevertheless, as we already know by now, electron orbitals do not have clear physical boundaries. This is why we have several definitions on what atomic radius refer to. They are actually all pretty similar. We know that the radius is dependent on how far the outermost electron is from the nucleus for most parts of time. Let's consider the trend now. Across the period, effective nuclear charge increases. That means to say each of the outermost electron is experiencing a larger attraction force from the nucleus. This results in a decreasing atomic radius for elements across the period. Down the group, the effective nuclear charge is no longer a good characteristic as there are no significant changes. Instead, let us look at the shells. Remember that for a larger nth shell, the electrons tend to be greater distance from the nucleus. This is the main explanation for which atoms are larger down the group.